Previously we do that single input, we are getting this single output. But here in this function, so see two inputs are giving. Okay, now order pair means two inputs are giving, we are getting the single output, this function. So according to that, he given the domain also, he defined like this. Two inputs given, that's why you have to two inputs taken from the two sets. Compulsory, he will represent like this, cross product only. So in G function, he given that, G function is given that single input is given. So the output is two values. That's why, so see this one, this output means codomain. Codomain expressed in the two sets cross product, Cartesian product. So this is the input values, you are getting the single input values, but you are getting the multiple input values, means always getting the order pairs. That is the meaning. Okay. So this is the domain value, this is the domain, this is the codomain, this is the domain value, this is codomain for this function. Okay, na? Okay. Now we are going to check it. First, these composite functions are defined or not. I already told you how can you check it. The second function codomain. What is the second function codomain? The Z circle Z, right? So which is same or subset or equals to the domain of the F. Yes, this domain of the F. Yes, both are the same. If both are the same, you cannot check it. You can say directly, you can say there is the defined composite function. Okay, first one is the defined function. Then how can you find the domain and codomain? I already told you, any composite function domain is nothing but domain of the G. G domain is Z. That's why you take in Z. What is the codomain of the composite function? First function F. F function codomain Z. That's why we can write the domain codomain. Later we can find the composite function in terms of X. You see, in terms of F circle G, you apply the X composite function. Okay, for this composite function, X is applied. Now remove the circle and write the G of X function in the bracket. Then this G of X can replace by this order pair. Okay, na? G of X is given, na? This G of X can replace by this order pair. So yes, F of, you write that order pair, X comma Z. Now if you compare this to F function, it is the last function is F function. You compare to X plus X only, but in Y place there is a mod X. So right side also same thing you can do. So you can remove this one, okay? In place right side, in place of Y, you can substitute mod X. In place of X, you can write X only. X into mod X is our composite function answer. Similarly, you can going to check the G circle F also. G circle F also. See, F codomain. F codomain is nothing but, what is the F codomain? Yes, Z. What is the G domain? G domain also Z. Yes. G subset equal to Z, integer values subset equals to Z only, na? Yes, it is true. Okay. Then this function is well defined function. How can you find the domain and codomain? I already told you now. What is the domain of this one? F domain, Z cross Z. Okay. What is the codomain? G domain, G codomain, Z cross Z. That's why you take the Z. Actually, you have to take it the Fx comma Y. Take it the Fx comma Y. Not a problem. F of X also not a problem. F of X comma Y, you can take it. Okay, na? Now you can take the bracket for the F of X comma Y. You also take the F of X comma Y. Then this F of X comma Y replaced by XY. Now, okay, na? Then only we can, why? Because XY we can, when we say F of X is not defined for XY. That's why compulsory, actually codomain representation, I think he made mistake, I think. That's why. So for taking the two inputs, first you apply the two inputs for the, why? Because for F function compulsory you have to apply two inputs. Then because of F of XY, you can replace that F of X by XY. Now this is the single input now. Okay, there is no comma, there is no order pairs. Now G of XY requires the single input, but you observe here wherever X, okay, na? See, if you compare this one, in place of X, XY is there. So that's why this XY you can substitute here and here. That's why you substituted this one. So in this way we got this answer.